And we are back with lesson 18. This time we are trying to see if an ordered pair satisfies a function, but we're given the function in the form of a table. So there's going to be a couple ways to do this. The first way is going to be really easy, and I'm going to show that way right now. The way to do the easy way, and the easy way is only available sometimes, unfortunately. But the way to do the easy way is just basically to see, hey, does the ordered pair appear in the table? And if it does, the answer is yes, because, well, duh, it's already there. So, in the case of A, we can say that yes, A definitely satisfies the function because it's right there in the table. And if we look for any others that are in there, there aren't any others that are in there. We can also look for anything where the x value or the y value matches what's in the table. So if I look at B, I don't have a 5 in the x spot or a 20 in the y spot. If I look at C, I don't have any negative numbers. But if I look at D, I can see that I have 8 in the ordered pair in the x value and in the table. But this 1 right here does not match with this 29 right here. And so for it to be a function and for it to work, for any one x value, it can only have one y value. And so that 8 could only be with 29. It can't also be with 1. So that's a quick way for me to be able to tell that D is not going to work, because 8 goes with 29, not with 1. So the only two that I have left to try are 5 and 20. Now there's a couple ways to do this. You could try to extend the table and that sort of thing. The way that I think is going to be easiest and I know is going to work every single time for me is to write an equation and then test those values in the equation just like we did in lesson 17. So we'll work on getting our equation here. This is changing by 6 in that spot, and then 12 in this spot, and then 3, and then 6. And so this is increasing by 2, then 4, then 1, then 2. And so we could use any one of those sets to find our slope or our rate of change. I'll use the first one, 6 over 2. So our rate of change is going to be 3. And so, again, you could use that to count up or down and find the missing value in the table. Or you can write an equation for it. I'm going to go ahead and write an equation for it. Now that I know my slope is 3, this would have to come down by 3, which would be 5. This comes down by 1, which brings it to 0. So my y-intercept is 5, and my slope is 3. So I've got y equals 3x plus 5 for this one. And so I'm going to need to do this twice. Sorry, I'm going to redo that here and scoot it over a little bit. Because then I'm going to have to do it twice, once for each ordered pair. And so my first one is going to be 20. I'm testing B here, equals 3 times 5 plus 5. And so 20 equals 15 plus 5. 20 is equal to 20. Yes, that's a true statement. So that would be in the table somewhere if I extended the table. And it does satisfy the function. The next one we have negative 3 and negative 4. So negative 4 is our y value. Negative 3 is our x value. And we've got negative 4 equals negative 9 plus 5. So negative 4 equals negative 4. Yes, C does satisfy the function. That would end up in our table if we were to extend the table. I'll leave this here for a moment for people to take notes and such, if that's something you need to do, and move on to 2. So for number 2, I will use the same strategy to start with. I do see that I have 0, negative 5 here, and I have 0, negative 5 there. They match perfectly. So B is a solution to the what's the word I'm looking for? It does satisfy the function. I don't see any of these other numbers of the x values in the table, and I don't see any of those numbers of y values in the table either. So I'm going to have to come up with an equation and test all three of those using my equation. So to get my equation, we'll run the slope really quickly. Slope is going to be 2 here, 2 here, 2 here, 2 here, and 1, 1, 1, 1. So slope is going to be 2. And our y-intercept is -5, so our equation looks like y equals 2x minus 5. And so our y value is -23 for part A, equals 2 times -9 minus 5. So -23 equals -18 minus 5. -23 is equal to -23. So yes, A would satisfy the function or appear in the table. We'll continue with B, testing B next. We did B. We already knew because it was in the table. Duh. So testing C. Same equation, y equals 2x minus 5. And so we're going to have 2 is equal to 2 times -1 minus 5. 2 equals -2 minus 5. 2 equals -7. That is not true. So C does not satisfy the function. And lastly, for this one, D, y equals 2x minus 5. 10 is equal to 2 times 8 minus 5. So 10 is equal to 16 minus 5. And 10 is not equal to 11. So D does not satisfy the function. So again, I'll leave this here for a moment to take notes and stuff if folks need to do that. And recognizing that basically what we're trying to do is see if these ordered pairs are in the table, or if we have an example like we did on the first one where there is something like what's in the table, but it doesn't match perfectly. And then creating an equation to test those that are left. So number 3, let's take a look at the table and the values that we have. I don't see any of the x values in there. And I do see one of the y values in there, though. I see the -6 here and the -6 here. And 6 is already with 0. It can't be with -18 also, so that one is gone. And then we don't have any of those other numbers, do we? Okay, so we can throw an equation together really quick. It looks like our y-intercept is -6, and our slope is going to be 6 on the right and 3 on the left. So slope is going to be 6 over 3, or 2. So my equation is going to be y equals 2x, and our y-intercept is -6. So we'll test that first point. We'll call this A. So y is 16, equals 2 times 11, minus 6. 16 equals 22, minus 6. 16 equals 16. Yes, that's a true statement. So A does satisfy the function. C, y equals 2x minus 6. Our y value is -22, equals 2 times -8, minus 6. -22 equals -16 minus 6. And so yes, -22 is equal to -22. And C does satisfy the function. Lastly, for D, y equals 2x minus 6. -26 equals 2 times -10 minus 6. -26 equals -20 minus 6. -26 equals -26. That does satisfy the function. So number 3, we have A, C, and D. So moving on to number 4. Let's investigate and see if we have anything in the ordered pairs that already is in the table. I see that I've got 3, 0 here, and I've got 3, 0 here. So that's going to mean that 3, 0 is automatically one that satisfies the function. And I don't have any other x values there that match. And I also don't have any other y values. And so I'm going to have to test a, b, and c. We also need a y-intercept. So the easy way to get the y-intercept on this one is 0 falls right between -1 and 1. And 6 falls right between 4 and 8. So our y-intercept is going to be 6. Our slope for this one looks like it's going down by 4 here, down by 4 here, down by 4 here, down by 4 here, up by 2 here, up by 2, up by 2, up by 2. So our slope is -4/2, or -2. So an equation for this one, y equals -2x plus 6. And so we'll test our a point A. We're going to have 6 equals -2 times 0 plus 6. 6 equals 0 plus 6. 6 equals 6. Yes, that is true, so that one satisfies the function. For B, y equals 2x plus 6. -6 equals 2 times 6 plus 6. It doesn't look like this one's going to work to me. -6 is 12 plus 6. -6 is not equal to 18. So no, B does not satisfy the function. Testing C, y equals 2x plus 6. 1 equals 2 times 4 plus 6. Doesn't look like this one's going to work out either. 1 equals 8 plus 6. 1 equals 14. That is not true. So C is also not one that would satisfy the function. I'll pause here before moving on. Okay. And so as I've done with previous lessons, I'm just going to do these videos as one page at a time. So yeah, that's going to be it for this video. I hope this is helpful. If you feel like you're able to tackle the rest of these on your own, you and your teacher can make that decision. But I will be making videos for the rest of them as well. Again, I hope this is helpful, everyone. Have an awesome day.